based on the decision tree algorithm, and then the 80% training and X-train and Y-train data, the decision tree regressor model was fit. The decision tree regressor model was fit. Now we will predict regressor.predict of, I will pass X test value, which can find Y predicted score. You can print actual Y test as well as predicted score. Then you can print a value. Then use the same metrics. So just a single line change. Linear regressor of which can execute linear regression. Decision tree regressor of which can execute decision tree algorithm. So this is what the machine learning algorithm works. One second. So all those things are available in the same website. So you can don't worry about that. Entire code was available. So all those algorithms and then code was available. Okay. Petrol consumption.csv. The data set also available. If needed, you can separately download the data set and execute in your machine. If you have any queries, anytime you can ping me via WhatsApp or mail too. So decision tree algorithm works fine. Now I am entering into my third stage. If this is not required, I am entering into my third stage. The algorithm of decision tree, which is common for both decision tree regression as well as classification. Regression in the sense you can predict the exact value, but classification, whether it's in class A or class B. But classification is concerned whether it's in class A or class B. Okay. So here there is another example. So the data set was created, downloaded. This data set, all the values are taken as X. The class 0 or class 1, which is taken as Y. Okay. So again, the same steps. I am repeat the same thing again because entire machine learning, only the algorithm name change was enough. Or you can just provide a data set and split an X and Y and pass 80% training and 20% testing. Then you can pass your algorithm name. It works fine. So machine learning was very easy with the help of Python library. So you can start developing your project or research work in machine learning using Python. Variety of libraries are available. So the same steps which followed here for decision tree classification. So step number 1 for import packages. Step number 2 for read data from dataset. Step number 1 for import libraries. 2 for read data from dataset. So dataset equal to pd.read CSV. 1 second, please. So pd.read CSV bill authentication.csv. Bill authentication.csv. So import dataset. So step number 1 for import packages. So whatever packages needed, you can import. After that, step number 2 for import dataset. Here I have downloaded the dataset bill authentication.csv. At last there is a class, whether it's in class 0 or class 1. Then now split X and Y. So dataset.drop. Anyway, you can use any kind of methodology, either use ILOC or directly place all those column name, or use drop last column class. It can omit the class column, all those other column taken as X. Only the last column class which is taken as Y. Something like this. So step number 1 for import packages. Step number 2 for read data from dataset. Step number 3, you can split whatever columns are mapped into X, and last column, actually the last column or any column which will be mapped into Y. Then again, this is anyway, you needed, you can change the test size too. Okay. Here train test split off is a method which used to split 80% data taken for based on test size, 80% data which taken for training, and 20% data which taken for testing. Okay. Now, so decision tree classifier, one and only change, please listen carefully. Linear regressor of, next we will place decision tree regressor of, here we will place decision tree classifier. Here we will place decision tree classifier. So this used to classify whether it's in group 1 or group 2. Just easy. Python is a very easiest language. It can very user friendly manner, it can support us for creating any projects or any research work. So just classifier dot fit of x train comma y train, then the classifier model, decision tree classifier model is ready. Decision tree classifier model is ready. X train comma y train. Then y predicted value, which is equal to classifier dot predict of x test value. Y predicted value equal to classifier dot predict of x test value. Now you can predict the value and you can compare with the actual value. This is classification. So the classification matrix is confusion matrix. At last I will explain confusion matrix, precision and recall. So I am using confusion matrix to print the score. Okay, I will explain confusion matrix in the last stage. Okay, I hope this is clear. Initially starts from linear regression, Python, machine learning intro, then machine learning application, then so at last the algorithm which will be evaluated with the help of the matrix which is called as confusion matrix. So I will summarize everything. So initially we'll start from the basic intro on machine learning. After that we are entering into some basic application. What are all the applications of ML? Then entering into the libraries required for developing ML algorithm. Then we are entering into a basic example of linear regression with the help of a student score data set as well as a simple data set. With the help of Colab, we have executed entire thing. Then we are entering into decision tree. That algorithm is supported for both classification as well as regression. We will see both classification example as well as regression example. Any questions? At last, we are entering into random forest and system metrics with real-time example. Any question from participant side? Please use chat box or otherwise unmute and speak, please.
How are you importing the data?
Please. I will repeat. I will explain. 1 second. Yeah. So in Colab, just you can this is the easiest one. So you can download the data set. I will give a data set URL. One second, please. Sorry. So initially, you can take a dataset URL. So I will go to the website, same website. I will go here. Then I will go to materials and Python. Here at last the data sets are available. So I will download studentscourse.csv. You can click on this URL. So the entire data set was available. I can download the data set. Yes, the data set was downloaded and placed in my downloads drive. Then I will go to my Gmail account and googledrive.com. So automatically it will go to my drive. Okay. Inside that I will create a new folder. The name of the folder is Python dataset, Python DS. I will create a new folder. Inside this Python DS folder, new file upload. I will go to my downloads and I will open studentscourse.csv and upload here. My file was uploaded inside this folder. Then I will go to Colab. I will go to Colab. I will open a new notebook. I will open a new notebook and I will copy paste these two lines from google.colab import drive and drive.mount of /content/drive. Automatically Google Drive which will be mounted. I will click here. Google Drive which will be mounted with my Colab. It will ask permission. So connect to Google Drive. It will ask mail ID. I will provide my email ID. It will ask a permission. I will click allow. Now I will add another section. I will use change directory cd /content /drive /my drive /python ds. I will change my directory to here. So yes, dataset was mapped into directory. Now I will be writing import pandas as pd. Then I will create a function that is ds dataset equal to pd.read_csv of my file name. I think actually uploaded in Google Drive. This is my file name. I will rename and copy paste my file name. So single quotes, I will place studentscourse.csv. Yes. File was mapped with the handler called as ds. Now I will place ds. Then I will execute the code, which will print the entire data set. These are the basic steps. Initially, we can map my Google. Then I will be change my directory into where the data set is available. Then I will import the package pandas. Inside the package pandas, there is a function which is called as read comma separated value. I will place my file name. Then the data set was read and mapped into a handler ds. Just I will print the handler ds. If needed, I will print ds.shapeof. Shapeof is a method we choose to print the number of rows and number of columns. Sorry, shape is a variable. So ds.shape, we choose to print number of rows is 25 rows, number of columns is 2 columns. So which will print everything. Is it clear? Any other questions? Please unmute.
भी बताएंगे क्या?
No? Any other questions? So this is what we have mapped a data set upload a data set into Google Drive, and then we can map it into our Colab. After that, we will use it for our machine learning algorithms. Now we are entering into our last stage of random forest algorithm.
सर आप डेटा प्री प्रोसेसिंग भी बताएंगे क्या?
Please.
Data pre processing.
I will explain next. Data pre-processing or feature selection. Here there is no data pre-processing is needed. Directly you have split the data and use that. I will explain pre-processing at the last stage. So the last one, which is for random forest, please. Random forest, here also there is regression as well as classification. Then at last, how to plot your data, and you are entering into real-time example of precision, recall, and F1 score. I will skip this because of time being. Yeah, the same way the random forest algorithm was taken. So all those algorithms, the common part is import packages. So import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT. Okay. Then download data from dataset. Yes. Then read the data from dataset with the help of the function pd.read_csv. The dataset which is named as petrol consumption.csv. Then here the same way, the 80%, initially all other column which is mapped into X and the last column which is mapped into Y. Same setup which is repeated again. Then same function. Then I will use the method which is called as train test split off. The method which is named as train test split off. With the help of the method, the 80% data which mapped into training and 20% data which mapped into testing. So here X train and Y train value which hold 80% of value, X test and Y test value which hold 20% of value. Then the scalar is not required. A scalar is one kind of feature scaling. If needed, you can map your value into some scaling. This is also one of the pre-processing. So skland, because in your question you are asking for pre-processing. So feature scaling is a kind of pre-processing. So skland that, because for example, here we can verify the value of petrol tax lies between 0 to 10, but average income which lies between 0 to 5,000. Highways, paved highways which mapped into something 2,500. Then population of driver license which lies between 0 to 1. So all those values are mapped into a standard scale of 0 to 1. All those values are mapped into a standard scale of 0 to 1 along with result 2. So for pre-processing data, because one data lies between 0 to 10, other data lies between 0 to 4,500, other data which lies between something 0 to 2,500, it's not a standard way. For giving a standard way to that data, you can use a pre-processing step. That pre-processing step which will be named as standard scalar. So here I will use a skland package. Skland is an excellent package. Inside that you are having all machine learning algorithm. Addition to that, all system metric. Addition to that, all feature selection as well as pre-processing function too. So from skland.preprocessing, you can import one of the pre-processing method which is called a standard scalar. So you can fit the transform into standard scale. So all the X train variable and X test variable would change into a standard scale of 0 to 1. So this is the kind of pre-processing, because one values are 0 to 10, second value is 0 to 5,000. So the mapping to a ML algorithm is typical. For avoiding that, you can use a pre-processing. That pre-processing stage which is called a standard scalar. So you can map all those values into standard scale between 0 to 1. Now X test as well as X train value which will be mapped into 0 to 1. Now you will place the algorithm which is named as random forest regressor of. random forest regressor. So here you will create multiple tree. Decision tree in the sense it will create a single tree. Here we will create multiple trees. For n estimator equal to 20. So it will create 20 tree, majority based on majority voting. Tree 1 says the student is pass. Tree 2 says the student is pass. Tree 3 says the student is fail. Tree 4 says the student is pass. So based on majority voting, 3 trees are representing the student is pass. So it says the result as the student is pass. So something like this. So here I will place the n estimator, the number of times executing the loop, it's for 20. Then regressor.fit of x train comma y train, which is similar. One and only change was a number of times the tree was created. A number of tree was created, or number of times the loop was executed. So then I will predict the value. Again the same. Everything was same. One and only different was n estimator equal to 20. The another difference was here we are using some pre-processing technique. For random forest is concerned, it can create multiple trees based on majority voting. It make decision. This is for random forest regression. Last, I am entering into random forest classification. So again, repeat the same. Import package, read data from dataset. I will split. All other column I will map into X. The last column I will map into Y. Then train test split off 80% for training and 20% for testing. The same thing. Now I will use the standard scalar preprocessor here too. Here I will use random forest classifier. The single change, linear regressor, then logistic regressor. Then I will change it into decision tree regressor. Then I will change it to decision tree classifier, random forest regressor, then random forest classifier. Just a single line change, the entire algorithm was modified and predict a different value. Whatever is fit for your data set, you can use the same. So at last you will print the confusion matrix for the same. So there are numerous number of metrics are available. Confusion matrix which will provide precision and recon value. It works fine. I will skip this algorithm for time being. Yeah. I will enter into performance metrics of machine learning. At last I will enter into performance metrics of machine learning. So some of the excellent performance metrics, the first one which is called as confusion matrix, the second one which is called as accuracy, the third one which is named as precision, the fourth one which is called as recall, the fifth one which is called as F1 score. I will explain with a real-time example. So I will take a problem statement. This is my last one. I will conclude soon. So this is my problem statement. So let us consider a task to classify whether the person is pregnant or not pregnant. So we will take an example. So now we are having the entire data set. The entire data set will be mapped into 4 stages. So the stage number 1, there are 4 classes. One is true positive, the second one is false positive, then true negative and false negative. There are 4 stages. So we are taking our example, the person is pregnant or not. Here the first part, actually the person is pregnant. The doctor also correctly identify the person is pregnant. So that will be called as a machine. Doctor in the sense machine. The machine can correctly identify the person is pregnant. So which is called as true positive. A machine can properly identify the positive is not a pregnant. But a machine can wrongly classify, that is a negative result. He is pregnant. So who is actually not a pregnant, the machine, the machine is also properly classified not a pregnant. So that is also true statement. So true negative. Negative was also correctly fine. A person is pregnant, doctor is also correctly fine. The person is pregnant, that is true positive. A person is not a pregnant, doctor is also correctly fine. The person is not pregnant, that is true negative. So two statements are fine. Now, the third statement, a person having big belly, but a doctor was wrongly identified, he is a pregnant. So actually, person having big belly, doctor was wrongly identified, she is pregnant, that will be called as false positive. So positive in the sense pregnancy, but the doctor was wrongly identified. Doctor in the sense the machine was wrongly identified. So that statement which is called as false positive statement. The last one, actually the person is pregnant, but the machine wrongly identified not pregnant. Actually pregnant, but it wrongly identified not pregnant. That's called as false negative statement. So here there are four classes. The class 1, true positive. The class 2, which is called as true negative. So machine was correctly identified positive, correctly identified negative. Then false positive, false negative. Machine was wrongly identified positive, wrongly identified negative. There are four classes. So I will take an example. We select 100 people. We'll select 100 people. Out of that 100 people, the 40 people are pregnant, 60 people are not pregnant. We'll take an example of 100 people domain. Among that, 40 are pregnant, 60 are not pregnant. Okay. We will classify it. So into the same classes, true negative, true positive, false negative, and false positive. Here my machine can identify there are totally 100 people. Actually 40 people are pregnant, 60 people are not pregnant. Among 40 people, 30 people my machine was correctly classified, he is pregnant, she is pregnant. But 10 people my machine was wrongly identified. 10 my machine was wrongly identified. So 30 machine was correctly identified. So the 30 which mapped into true positive. 10 my machine was wrongly identified. So the 10 was false negative. Then similar way, there are 60 not pregnant people. 55 was my machine correctly identified as not pregnant. But 5 my machine was wrongly identified as pregnant. So the 55 which is taken into true negative, the negative was correctly identified. 55 people, my machine was, I correctly identified the negative statement. So that is true negative. But 5, my machine was wrongly identified. That is false positive. My machine says positive, but it's wrong. So that is false positive. So that is taken into example. So here 55 was true negative statement. 30 was true positive statement. 10 was false negative statement. 5 which is considered into false positive statement. Okay, this is the predicted label. The accuracy was found with the help of a simple formula: true negative plus true positive divided by all sum of all. True negative plus true positive, whatever true, whatever my machine correctly identified, that is 55 plus 30, that is 85 my machine was correctly identified, divided by 100. So my machine accuracy was 85%. It's well and good, but accuracy is the best measure. I will take another example. If the data set was balanced, I think 40 people are pregnant, 60 people are not pregnant. So data set was little more balanced. In that case, it's worked fine. I will take another example. 90 people are healthy, 10 people having disease. You can think about that. 90 people are healthy, 10 people having disease. I will take another example. So here, my machine identify 90 people having and not having disease is the healthy people. System can correctly identify 90 people are healthy, but only 10 people are having disease. System can wrongly identify all the 10 people. System can wrongly identify all the 10 people. 10 people also healthy. Actually, I'm having 100 people. Among that, 90 people is a healthy people. 10 people are having disease.